So chapter 13 is on taking a graph of something that we know and then shifting it and dilating it and reflecting it and doing all different things to get something that looks more complicated, but basically it's the same function but just done a bunch of things to it. So then we can graph something that is complicated looking by starting with something easy and then by doing all these operations to make it look like a complicated equation. So 13.1 is a simple example of that. So first they're showing to graph all these lines. So like y equals negative x plus the square root of 2, and show that all these different lines here, so the other one is negative x minus root 2, and then it's positive x plus root 2, and positive x minus root 2. And graph all these things and show that they make a diamond which the unit circle fits in. Okay, so first the idea for graphing these is we start, and I'm going to try to do this neatly, wish me luck here. So here is our axis, and we start with something we know, like y equals x. Y equals x is easy, that's just this line here, 45-degree line. Y equals x, we know that, that's what we know. This is y equals x. And then, okay, let's start with the positive one. So this is y equals x, but we're adding root 2. When we're adding root 2 to our y, that just means it raises up by root 2. So let's say that square root of 2 is right there. That's square root of 2. So now our line, it looks like this. So there, oops, okay, it's hard to do it neatly. So there's y equal x plus root 2. Now y equal x minus root 2 would just be down here. So here is y equals x minus root 2. So y equals x minus root 2. You shift it down by root 2. So this is negative root 2. And then negative x means you take x and you reflect it. You take it from here and reflecting about the y-axis, so whatever is positive becomes negative. So it's basically going this way, right? So I'll draw y equal negative x. Reflected, again, here's x, negative x, so this is y equals negative x. And then we do the same thing. We add root 2 to it. So we go up by root 2 to right there. So here is our other one. And I should hit that point right there. Okay, I knew it was going to be messy. Y equals negative x plus root 2. And then we take away from it, it goes down to here. Minus root 2, something like that. This is y equals x minus, negative x minus root 2. Okay, so here's our not so pretty diamond. They should be right angles there. That is formed by all those lines. Okay, right. Okay, I'm just making this worse. Okay, there's our diamond. Then part A, actually doing the work, says show that the unit circle sits inside the diamond. So we want to show that a circle of radius 1 sits inside here like that. So basically we just need to show that this point hits this line once. Okay, and the circle hits this line once. This circle hits this line once and hits this line once, and that's pretty much showing it fits in. So let's choose, let's choose this point right here. Okay, the circle of radius 1 is x squared plus y squared equals 1 squared, which is 1 because it's centered at the origin. That's nice. And this line here, we'll just start with this line, is what, y equal negative x plus root 2. So y equals negative x plus root 2. And we want to show that they hit in only one place. If it like missed the circle, it hit in 2 places, or it wouldn't hit at all. So if it only hits in one place, that means it's tangent there. It doesn't hit the circle twice or not at all. And then that's all we have to show. Okay, so let's show that these two equations work. So let's square y over here. So y squared is, let's see, this squared That'd be x squared plus that plus 2 times them multiplied together, which is minus. So minus 2 multiplied together is root 2x, so root 2x. That's y squared. Plug that in for y squared here. I'm going to try to be neat. X squared plus all this stuff. X squared plus 2 minus 2 root 2x equals 1. Okay, now we will put the 1 over here, and the x squareds go together, so we have 2x squared minus 2 root 2x. We'll see minus 1 make plus 2 makes that a plus 1 equals 0. And we want to solve for x now. What x value makes this true? Looks like we're going to have to use the quadratic formula. So x is equal to negative b. Let's see, b is all this, which is already negative, so it makes it positive. So 2 root 2 plus or minus the square root of b squared, this squared. Let's see, this squared is 4, makes it positive, of course. 4, 2 root 2 squared is 2, so that's 8. So 8 minus 4ac. 4, I'll just write that out, times 1, c is 1, times a is 2. So times 2, not times 12, that's times 2. All over 2a. And a is 2, so all over 4. Okay, well, this is nice. See, this is going to, we have a plus and minus, is going to give us 2 answers. That's bad. However, 4 times 2 is 8, so this is 0. So I think this is called the discriminant. The discriminant is 0, the square root part's 0, because 8 minus 8 is 0. That means there's only one answer. The only possible answer for x is 2 root 2 over 4, which is the square root of 2 over 2. So there's only one place where it intersects at root 2 over 2. That point there is x is root 2 over 2. And so therefore, the circle does fit in. It only hits that line at one point. And we could go through and do the exact same thing, changing the things in negatives and show that it only hits at the other 4 points. But really, you can do that if you like. But if it works for this one, it will work for all the other ones. You can easily convince yourself of that. So we did part A. Hooray! I should write an A here somewhere. Here, A. There's part A. Okay, now let's do part B. B says, find the intersection points between the unit circle and each of the 4 lines. Find the intersection points between the circle and each of the 4 lines. Okay, well, we just found one of them. This intersection point is root 2 over 2. By symmetry, this one over here is also going to be root 2 over 2. So the first one is root 2 over 2 and root 2 over 2. This one down here is going to be the same thing, but now the y is negative. So that one is going to be, let's see, x is still root 2 over 2. The other one is negative. Y is negative root 2 over 2. You get the idea. The other point, this one over here, now the x is negative. So negative root 2 over 2, root 2 over 2. And then they're both negative for this last point right here. They're both negative. It's always going to be root 2 over 2. So negative root 2 over 2, negative root 2 over 2. I suppose I should put parentheses around these to make them look like points. Okay, those are the intersection points between the circle and the lines in each line. Okay, now finally, let's do C. C is a trickier one. They say, construct a diamond-shaped region in which the circle of radius 1 centered at negative 2, negative 1 sits tangentially. Use the techniques of this section to help. Okay, so this is where it gets to be kind of fun. We want to show, and I'm going to start with a brand new sheet of paper because otherwise I'll write too small, and that's always a problem. So we want to show, let me write C here again, that this circle, we want to find lines to cut this new circle. So first we got to draw the new circle. So I'm going to try to do this neatly. Here is my graph. Probably didn't make it big enough. We want the circle to sit at -2, -1. X equals -2. Let's make that right here. -2, so 1 would be half of that. So here's -1. So this circle would sit right here. It's got a radius of 1. This is -2, so it goes up to here, down to here, to right here, to right here. Oops, that's a little bit far over. So I'm using a pencil to right there. Okay, now I'm going to try to draw a circle that hits those dots. My circle there messed up a little bit, but oh well. Put some paper underneath here so that writes better. Okay, here we go. So there is our circle. We want to find the lines. Ah, God, that's terrible. Well, okay. We want to find the lines that go like this, that make our circle, that hit, it's supposed to hit right there, that hit our circle just once. Okay, what are those lines? All right, now, it's a lot the lessons of this chapter make this easy, so kind of. So here's how it works. We shifted our circle over. We took the unit circle, which was right here, and we shifted the center over 2 in this direction. So we shifted it this way 2, and then we shifted it down 1. And it doesn't matter which order you do it, but for this case. But normally you do the x first. So you shifted x to the left 2, and you shifted the y down 1. So all we got to do is take our lines that we just had and do the same thing to those. Okay, so the first one they gave us is y equals -x plus the square root of 2. Okay, now we replace the x with an x plus. Okay, here's always the weird thing too. If we shift the x to the left, the x becomes x plus 2. That's when we add 2 to the x, it shifts it to the left, which is kind of always the opposite of what you might think. In the y direction, it actually makes sense. The y one, we're shifting it down 1, negative, so the y becomes y minus 1. We're just taking away 1 from the y, and that one makes sense. But for the x, if we add 2 to the x, that's shifting it to the left. Okay, so here we add 2 to the x first, so then we get y equals negative, oh, there's the x, we add 2, x plus 2 plus root 2. Okay, now this is the tricky part. We add it directly to the x, replace the x with x plus 2, which is, writing that simpler, -x minus 2 plus root 2. That's one of them. Then, the second one they gave us was -x minus root 2. Oops. This is why I'm doing use a pencil. I forgot the second step. Now we got to add 1 to it. So this is our new x. First we shifted it, placed x by -2. Then we take away 1 from the y. So we just take away 1 from this. So then our y, then take away 1 would be -x minus 2 minus 1 plus root 2. Take away 1, doesn't matter where we do it. So finally it's -x minus 3 plus root 2. Okay, first we take away, add 2 to the x, and then take away 1. Now we do that for the second one. Our second one here is y equals -x minus root 2. Y equals -x minus root 2. Okay, so first we change the x to an x plus 2. So y equals -x plus 2. And we can also just take away 1 from it right away. So it was minus root 2 minus 1. And let's see, that's -x minus 2 minus 1, so minus 3 minus root 2. The same thing, the next one here. So 3 is x plus root 2. Y equals x plus root 2. And we just take away, place the x with x plus 2, so it's x plus 2 plus root 2, and then take away 1 and you can put that together and make that work. So that would be x plus 1 plus root 2. And finally, y is equal to x minus root 2. Place the x with x plus 2. So that's equal to x plus 2 minus root 2. Take away 1 from the y. And so we get x plus 1 minus root 2. And if you were to graph all of these, you will find that they perfectly, you can try Desmos as your friend for this chapter, use it a lot. You can plug all these things in. It's kind of a lot of work, not too bad. And you'll see that it graphs, here's your circle, and you'll see that it makes nice diamonds around it. Okay, hopefully that helps. This stuff is tricky. I'll make more videos showing how to do these, but hopefully that helps kind of get the general idea here.